Okay, good evening, everybody. Welcome to this short video on the introduction to Python and computer programming. Okay, today we are going to learn about we're going to learn about what is computer programming, right? We're going to understand what does it mean when we say what is a program? How does the program execute? How does the computer execute the program? How do you write programs? We're going to learn about programming languages, how they were created, and how they are defined. We're going to also learn between the difference between what is a compiled and interpreted language, what is Python, and then we're going to learn what makes Python different from other languages. Yes. So, what is a computer program? Right. A computer program is essentially a set or a sequence of instructions, right, that you give a computer to perform. The modern day designer of or rather, the designer of the modern day computer, John von Neumann, designed a computer essentially to execute programs one after the other, right? And what we have now in modern day times is that we have programs that are written in human readable languages and are translated and executed in machine code, right? So what is a programming language? Okay. So a language is essentially just to talk about a language, not necessarily a programming language, but a language is just essentially a tool used for communication, right? You use it to communicate with either people or animals have their own language to communicate with one another. Essentially, it's just a tool to communicate, right? So a programming language is essentially a tool that you that you use to communicate with a computer, and you essentially give a computer instructions to perform a specific task, right? So here's examples of some popular computer programming languages. I don't know if you've heard of some, but today we'll be learning about Python, right? So computers have their own language, right? And they don't understand English, unfortunately. They understand machine code, ones and zeros or hexadecimals, right? So now we are going to create a language that we can understand, and then that language will now be compiled into a language, or rather translated into a language that the computer can understand. So what makes a language, right? Essentially, there are four things that make a language, and we'll go through them in this slide, right? Right. So the first one is a set of symbols, right? An alphabet essentially is a set of symbols that we use to build the words of a certain language. You can think of the Latin alphabet for English. If you think about other languages, you can think about the kanji for Japanese and the Cyrillic for Russian, right? So every language, right, essentially needs some symbols that you use to write words, right? And then you have a lexis, right? So it's essentially a dictionary of all the words that in this language, right? And then you have the syntax. So the syntax is essentially the set of rules, right, that are used to determine if a sequence or string of words, right, are valid, right? So that's the syntax. Semantics, and finally semantics, right? Semantics is another set of rules, right, to determine if the sequence of words makes sense. So it can be syntactically correct. However, semantically, does this make sense? No, it doesn't. Or yes, it does. That's the whole purpose of semantics, right? So if you have all of these, right, these four components, you will get a language. Now, we're going to be talking a lot about high level programming languages. And essentially, they are the languages that are human readable and are executed by the computer. Let's get straight to it, right? So high level languages, right? So like I said earlier, computers can only understand machine code. They can't understand English, right? So high level programming languages are essentially similar to natural languages and allow programmers to write complex computer programs, right? So remember, programming languages are essentially like a way for us to communicate with the computer, right? So we want it to do something, we want it to solve specific tasks, right? So now when you're designing these things, right, when you're designing a programming language, essentially what you want to happen is that you want to be able to communicate with the computer to write a task. However, or to execute a task. However, the computer does not understand English now. So you have to be able to ensure that this programming language that you write will be compiled into a code that the computer can understand, right? Now, a computer program written in a high-level language is referred to as source code. Now, what are the characteristics of a high-level programming language, right? So now, remember, I've been talking about this for quite a while. They have to be human readable, right? It's easy for the human to understand the syntax. Otherwise, then we would just go back to machine code, writing in binaries and hexadecimal, right? It defeats the point of high-level languages. So the set of words, lexis, right, is similar to human natural language. And in a single line, essentially, you can accomplish multiple tasks, right? And remember, the whole point of this language is to communicate to the computer to solve a problem. So high-level languages are problem-focused. So essentially, you'll have some high-level languages that are specific to a problem. So they're essentially maybe using for servers, or you're using for web scripting, or you're using for data analysis. They're solving a particular problem, right? Let's move on. So in the image below, you can see that there's a low-level language, which is just ones and zeros that the computer understands. And then you now see on the right, you have a high-level language. As you can see, sale price is English. I can understand that sale price equals to 1.6. And it says if, okay, what if the sale price is greater than 2, right? That's still understandable and human readable, right? You give a discount that is 0.1 or 10%. If it's not, the discount is 5%. And then in the image, you can see that since low-level languages are in a language that the computer can understand, it executes it faster, right? It can process it faster. It doesn't have to go through the whole translation step that it would have to do with a high-level language. Now it has to take it from this human readable, now it has to compile it into a machine code and then execute it. So the processing time would be a lot slower. Okay, so now we're going to delve into a bit of the history of high-level languages, right? So in like pre-1949, essentially what coders used to do, they used to write instructions one by one in binary and hexadecimal, which was not the best use of time, and it was also prone to errors, right? You had a lot of errors occurring because it's quite tedious. You have to write it line by line, probably on a chalkboard or something. And then in 1949, this guy called John Mockley, I'm not sure if I'm pronouncing correctly, developed short code that was used to represent commands to represent machine instructions, right? And then in 1957, Fortran was developed, and this was the first standardized computer language, right? So it had its own rules, and it was agreed upon. So it was the first standardized computer language, and it was used mainly for, or it was used for scientific and mathematical problems. And then in 1959, a very popular language was called COBOL, Common Business-Oriented Language, and a lot of architecture or corporate finance was built on this program, okay, or using this program. And then now we go into the difference between compilation versus interpretation, right? So compilation. So essentially, in a compiled language, you would have like another program that does the translation from your human readable code and translates it to the machine executable code. And essentially, this process is done once. So when you're done writing, you compile and you run, right? And then, however, if you make a change, you have to do the whole process again, right? So that is essentially compilation, a compiled language. And then once you compiled it, since it's now in machine code, you get, if you're working on a Windows computer, you'll get like an executable file, .exe, and you can transfer that file across. So essentially, the person that you give it to does not have to have this specific high-level language in order to execute the file, right? Examples are C and Golang and others, right? So interpretation is another type of high-level programming languages. So essentially, this program translates the source code to machine code every time the program is executed. So there's no extra step here. So remember in the previous one, I write my code, I compile it, then I execute it. Here, we just go straight to execution. And then if there is a problem on the way, we stop, right? There's an error that gets thrown up. In the compilation, the error gets thrown up when you compile. So it says, oh, there's a problem here. We can't execute this code. You have to fix it, then we recompile again. Not the case with the interpretation. You just run directly. If it causes a problem, you fix it. So the interpreter is needed by any computer that wants to execute the source code, okay? Which is different than the compiler, where you just have an executable. And examples of this are Python, JavaScript, and PHP. Now, what are the disadvantages and advantages of compilation versus interpretation? So you would have, on the compilation, remember the translated code is executed faster, it's already compiled, right? And now you just have you have it in machine code. The end user does not need to compile, does not need the compiler to execute the code. The translated code is stored in machine code. The disadvantage of compilation is that the process can be time intensive, right? It can take a lot of time. And now interpretation, what are the advantages? There are no extra steps required. Once completed source code, so you just execute, you don't have to compile. You just hope that you don't make any errors when you're writing your source code, so just execute. If there are errors, you have to change them, or you have to solve them, right? So code is stored in a high-level language. We don't need to compile the code for each different architecture. Maybe if you working in different operating systems. So now interpreter, the disadvantages you have, remember, the interpreter is essentially interpreting your human readable language and then interpreting it into machine code. And this process takes resources. So it's essentially a bit slower in terms of processing. And then the creator and the end user need the interpreter to execute the code. Okay, so now we get to why we're here today. Python, right? So what is Python, right? Python is an interpreted, object-oriented, and high-level programming language with dynamic semantic use for general purpose programming, right? So this program was created by a guy called Guido van Rossum, and he essentially named this program after a popular BBC TV show called Monty Python's Flying Circus. And essentially, he had these goals for Python when developing. It has to be easy and intuitive, open source. I mean, everybody can see the architecture, the code that used to build it, understandable and suitable for everyday tasks, right? So that is essentially the goals for Python. And if you look at it today, essentially, well, he stayed true to those goals. And Python is quite easy and intuitive to use and understandable, and it's a general purpose language. You use it in a lot of places, as you will see. So why learn Python, right? So why is Python a popular language? If you go to one of these popularity index, you see that Python is always programming popularity indexes. You see that Python is usually in the top 5, if not top 10, top 5, top 2. You're right, consistently, right? So it's easy to learn, right? So essentially the learning curve of Python is not as steep as other programming languages. And essentially this means that we can get to start programming a lot faster, right? It's easy to teach since it's easy to learn. It'll be easy to teach. Python is easy to teach since it's easy to learn, and there are no complicated constructs that need to be explained before using the language. You don't need to know computer science magic tricks in order to understand how to use Python, right? And it's easy to use, right? It's Python's simplicity, right? It makes it ideal for writing software, right? Which makes it possible to write code quite quickly, right? It's easy to understand, right? Easy to learn, easy to teach, therefore, it should be easy to understand. Due to its simplicity, understanding of other programmers' code is quite easy. So when you see somebody's code, you'll be able to read it. Hopefully they'll put comments as well, but you should understand. And also it's easy to obtain, install, and deploy, right? Python is free and open and multi-platform. I will show you where and how to download Python. Right, so where is Python in action? Excuse this blurry image, but so you can see it's used in graphical user interfaces and Django for web development, machine learning, and data sciences is quite good. So Python is broad, right? It's used every day and everywhere, all right? It's used in search engines, cloud storage tools, social media, a lot of places. Whenever you see the services like on you, I'm sure you will appreciate that Python is quite close. Right, so internet services, data analysis and science, machine learning and AI, and in systems architectures, right? So there are 2 version types, right? There's Python 2 and Python 3. They are not compatible with each other, all right? So Python 3 is the recommended version to use when learning Python programming. So Python 2 is the older version of the original Python, while Python 3 is the current version. There is no current development or additional add-ins on Python 2. They're just regular updates because there's a lot of systems and programs that are built on top of Python 2. So essentially, they're just regular updates to fix any bugs or security issues that occur, right? So if you're learning Python, Python 3 is recommended, right? Downloading Python, right? So let me show you where. So you will go to python.org/downloads/, and then for Windows users, right? So the operating system will tell your browser, your browser, okay, what operating system that you are using. And for Windows, just start the download executable file and follow all steps. Use the default settings except for, when you get to the option that says add Python to path, you select that, right? And that makes it easier down the line. And then for Mac users, Python 2 might be pre-installed, and you install the relevant package file from the site, and just like before, follow the steps. Okay, thank you very much for this video. In the next video, we will get into just downloading or using Python. We'll write our first Python program on VS Code. See you then.